Welcome to the final lesson in coordinate geometry. We've learnt a whole range of skills up until this point about how to deal with linear and non-linear equations. I'm focusing a lot more on the linear side of things and just briefly mentioning that there are non-linear equations and you do have to be able to recognize them by name and their shape. This lesson is going to be focusing on the geometry side of things more than anything, and the fact that you will be asked questions that look very much like this. You will be given information, you'll be asked to find certain things, and you need to just go ahead, use what you've got. You have no direction about where to start. You just need to know your stuff, know what you need to find your equations, and go from there. So for us, our best equation that we have is y minus y1 equals m outside of x minus x1. And we know we need a gradient and we need an x and y coordinate. And that's all we need to make that equation happen. So having a look at the question A and B, we need to find some equation of lines. So we're going to be using our point gradient form. First off, at question A, we need to find an equation of the line L, which looks to be that yellow line there. What we need is one point and the gradient. Now, here is the point 5, so I'm going to use that and my 3, -5 coordinates. To start off with, we need to work out the gradient. So the gradient is equal to the rise. My graph rises from -5 to 0. So my graph has a rise of 5, and my graph runs from 3 to 5, which is 2. So my gradient is 5 over 2. I'm going to pick the easy coordinate of 5, 0, because it has a 0 in it, so I don't need to worry about what will happen as my y1, because it just disappears. So I have y minus my y1 value of 0 equals my gradient of 5 over 2 outside of x minus my x value of 5. Filling this out, I don't need to do anything over on this side. Multiplying my brackets out, I get 5/2 of x minus 25 over 2. And there's the equation of L. Okay, moving on to part B, we need to find the equation of the line K, which is our green one. So we have the same point over here being used, and we have a new one of -2, 5. So here is our B. We need a gradient. Now, this line K, it goes from 5 and it drops all the way down to 0. So it has a rise of -5. And it goes from -2 all the way to 5. So it has a run of 7. So the gradient is going to be -5 divided by 7. Using our equation, we have y minus a y1 value. Again, I'm going to use the 5, 0 just because it makes it easier to clean up the left-hand side, equals -5 over 7 outside of x minus our value of 5. So I'm left with y equals -5x divided by 7 plus 25 divided by 7. You can clean that up and put it all over the one denominator of 7, but I'm going to leave it like that because I have a feeling that we're going to need to use that equation again. So moving on, question C, if the point 7W lies on our L, find W. So remember, L was the first one we found, and K is the second one. So we're going to need to use L to work out what y coordinate will fit the equation 7W in our line. So giving ourselves some more room, we're going to be answering part C. The equation we need to use is y equals 5 over 2x minus 25 over 2, and our coordinate that we're given is 7W. So we have an x value of 7 and a y value of w. So if we simply substitute those values in instead of x and y, we'll eventually be left with what we need. So our y value is now w equals 5 over 2 multiplied by 7 minus 25 over 2. 7 5s are 35, so we have 35 divide 2 minus 25 divide 2. That's going to leave us with 10 over 2, which will be 5. So therefore, W equals 5. And if you really want to get into it, the coordinate would be 7, 5 that lies on our line L. That's all there is. The last one, if the point T11 lies on K, find T. So over here we're going to answer D. Our point is T11 and we're going to be using our line K up here. So we have Y equals negative 5x over 7 plus 25 over 7. Instead of Y we have 11 equals negative 5t plus 25. I'm going to join them up all over 7. The reason I'm going to join them up is because with the 1 multiplication I can get rid of that 7 and end up with 77 equals negative 5t plus 25. I need to get rid of that 25, so I'm going to take it away. 77 minus 25 gives me 52 equals negative 5t. Then lastly I'm going to divide by my negative 5 so I can separate those. So t is going to be equal to negative 52 divide 5, which can be roughly equal to negative 10.4. So to finish it off we say t equals negative 10.4. And there's our final answer. Okay, just a little recap. Notice how we weren't really given any direction on where to go and how to start it. We were given some information, we're asked to find equations and then use equations. We need to know what form of an equation we would like to use to get to our answer. You could have went along and using extremely challenging methods worked out the y-intercept of our lines so that you could use the gradient intercept form, but as I've tried to say every time we've used it, the point gradient form is really your life and time saver here. So use that as much as you can, work through all the working out to find the answers you need to solve. Thanks for watching this video and good luck with your coordinate geometry.